Air Conditioning Service Calls, Part 1.
Hi, my name is Alan Pratt. All air conditioning equipment is classified as either standard efficiency or high efficiency. In this program, you'll see how two technicians use their troubleshooting skills with both types of equipment. But first, let's take a minute to review what is meant by standard and high efficiency.
The Air Conditioning and Refrigeration Institute has established normal system operating characteristics for both types of units. These characteristics are based on standard operating conditions, known as design conditions. Design conditions include an outside temperature of 95 degrees and an inside temperature of 75 degrees with a humidity of 50%.
Under these design conditions, air conditioning equipment is supposed to operate at its rated capacity and efficiency. Here's an example.
When standard efficiency R22 equipment is operating at or near design conditions, the evaporator coil temperature should be 40 degrees with a suction pressure of 70 psig, and the condensing temperature should be 125 degrees with a head pressure of 278 psig.
High efficiency units have larger evaporators and condensers, so their operating characteristics under design conditions are slightly different.
With high efficiency units, the evaporator coil temperature should be about 45 degrees with a suction pressure of 76 psig, and the condensing temperature should be about 105 degrees with a head pressure of 243 psig. Whenever high or standard efficiency equipment operates above or below the standard design conditions, the operating characteristics of the unit will change accordingly. For this reason, some manufacturers furnish a unit performance chart which shows what the suction and discharge pressures for the equipment should be under different operating conditions.
Now let's take a look at a typical service call that illustrates why it's important to know a unit's operating standards. Notice how the technician looks for the obvious causes of the problem first, by verifying the customer's complaint, asking the customer questions, and doing a visual inspection.
You arrive at the church office knowing only that the air conditioning unit is not cooling. So start by asking questions.
It was nice in here yesterday, but when I come in this morning, it was really hot and humid.
Where's your thermostat located at?
It's in the next room here, and it takes care of 2 rooms and the office.
What is your setting on the thermostat?
That's a 55.
That seems to be an awful low setting.
Well, part of the reason for that is that the volunteers who are working in the end room in the afternoon when the sun really starts to come in, it gets awful warm, and so they turn the thermostat down.
So you're telling me that the thermostat gets changed quite a bit?
It gets changed regularly. My preference is that it's 72, but it was turned down to 55 last night, and it was 55 all night.
All righty, let's take a look at it.
Start by verifying the facts of the situation. The thermostat in the middle room is set at 55, but the room temperature is 80 degrees. A quick check of the supply register in the corner room reveals that there is no air coming out. Next, check the air handler located in the attic. The suction line is covered with ice. The air filter is clean. However, the evaporator is totally iced over and will have to be defrosted.
Okay, the first 3 steps of the troubleshooting process are complete. The iced evaporator coil is the obvious problem, but there could be an underlying problem that caused the evaporator to ice up in the first place. Now, to find out, you'll need to defrost the coil and test the system.
Start by turning the unit off. Then attach a lock and tag.
If it's not accessible, the evaporator coil can be defrosted simply by allowing the blower to circulate air over it.
In this case, the evaporator coil is accessible. It can be defrosted either by spraying hot water over it or by using a heat gun. Here, a heat gun is more convenient. Once the evaporator coil is defrosted, reassemble the unit, remove the lock and tag, and turn it back on. Now you're ready to test the system. Set the thermostat at 72 degrees and check the airflow at the supply registers. The airflow is cool. Also check the suction line and the liquid line. The suction line feels cool and the discharge line feels warm, which indicates that the refrigerant system is absorbing and rejecting heat from the building.
The root cause of this problem, the thing that caused the evaporator to ice up, seems pretty obvious. The thermostat was set too low and the system was running all night under a light load. But you can't afford to make assumptions. Yes, the unit is up and running, but to find out if it's up and running correctly, you're going to have to test the system.
A good way to check the system's performance is to measure the air temperature drop across the evaporator coil using this simple formula. Return air temperature minus supply air temperature equals the temperature drop. First, use a sling psychrometer in all 3 rooms to determine the load on the system. Enter the wet bulb and dry bulb readings into the charging and airflow calculator to find out what the supply air temperature should be for this system under these conditions. Next, check the actual supply air temperature. Here, the supply air temperature falls within the calculator's requirements for this system's load conditions. Complete the service call by explaining the repair and service charges, making sure paperwork is complete, and answering any customer questions.
Will this problem reoccur again?
Yes, it will. It'll come back again. It'll be back. If somebody turns that thermostat down to 55, she's going to come right back.
So what can we do to eliminate that?
Well, you could get a lock on the thermostat, or you could get some Venetian blinds back there to maybe cut the heat down, set the time that the sun is the hottest, get that heat out of that room back there. You could tint the windows, or you might even think about doing some changing on the ductwork.
In this service call, the technician took extra time to discuss a long-term problem with the customer. The back room is exposed to direct sunlight in the afternoon and gets too hot. Now, unless that problem is solved, the people in the back room are likely to continue to set the thermostat too low and the evaporator coil will ice up again. Well, now let's take a look at a residential service call with a different twist.
Start by finding out what you can about the problem from the customer.
I understand that you're having some problems with your air conditioning system.
I certainly am. I used to have it set at 75 and it was just fine. It's gotten warmer in here and I've turned it to 70 and it's still warm, as you can feel, and it continues to be running.
Yes, it does feel very humid in here today. Tell you what, why don't you let me take a look at it for you. Can you show me where your thermostat is?
Certainly can. It's back this way in the dining room.
Thank you.
As the customer said, the thermostat is at 70. The thermometer shows 80 degrees. The air coming out of the supply register feels somewhat cool and the flow seems adequate, but the air in the house feels humid. Next, go to the basement and check the air filter. It's clean. However, the suction line is warm and the liquid line is hotter than normal. An examination of the condensing unit outside reveals that the coils are clogged with grass and dirt. Dirt acts as an insulator and reduces the ability of the condenser to reject heat to the outside air. This prevents the refrigerant vapor from condensing to a liquid and subcooling in the design range.
Clearly, the dirty condenser is at least part of the problem and should be cleaned thoroughly. Before cleaning the condenser, you should check its current performance. This will establish a baseline level for you to compare against after you clean it.
Since this is a high-efficiency unit, The condenser is designed to condense the refrigerant vapor to a liquid at about 20 degrees above the outside air temperature, and subcool the liquid refrigerant between 15 to 20 degrees below the saturation temperature of the refrigerant. The outside air temperature is 98 degrees, but the condenser discharge air temperature is only about 108 degrees. It should be at least 118 degrees.
Mr. Jones, I had the opportunity to check your unit outside, and it does need to be cleaned.
Explain the
There's
problem
grass
to the
inside of it,
customer,
and it's all
how you will
clogged
go
up.
about cleaning the
Just really need your
condenser.
permission to take care of it, and it's just a matter of
Estimate
us
the
figuring it out
cost,
out there for
answer
you.
any questions,
It's gonna
and
be
get
about
approval
$30
before you
for it.
begin.
That would be fine.
Okay, fine. Thank you very much.
Next, turn off the unit and make sure it's locked out and tagged. Remove the fan and grill cover to gain access to as much of the inside surface of the coils as possible. An extra-strength alkaline caustic cleaner is the best choice for cleaning air-cooled condensers. Its foaming action cleans the aluminum fins without danger of corrosion, even if rinsing with water is not possible.
Make sure you wear the proper safety gear when working with these caustic solutions. This will help you avoid breathing noxious fumes or getting the solution on your skin, on your clothing, or worst of all, in your eyes.
Proper protective gear should include an apron, face mask, goggles, and rubber gloves. Make sure to follow the manufacturer's instructions when preparing whatever cleaning solution you're using. Here, the instructions require you to use a low-pressure plastic sprayer. Add the water to the sprayer first, then the cleaning solution. Remember to keep the cleaner bottle closed when not in use. Before spraying, remove loose debris by hand. Then, spray the solution onto the dirty condenser coils. Leave the cleaner on the condenser coils for 15 minutes. Then flush the condenser coils with water, making sure to flush in the opposite direction of the airflow if possible. After the cleaning is done, rinse the sprayer thoroughly. Clean any spills from protective clothing and accessories, and wash thoroughly. Now that the coils are clean, replace the fan and grill cover, remove the lock and tag, and turn the fuse disconnect back on.
Now you're not done until you test the system. It's the only way to know if there are any other problems.
You'll need to know the operating pressures, so hook up your pressure manifold gauges now and allow 10 to 15 minutes to get an accurate reading. To determine the amount of superheat, use this formula. The suction line temperature minus the saturation temperature equals the amount of superheat. To get the suction line temperature, attach an insulated temperature probe to the suction line. Then, to calculate the saturation temperature of the low side, read the low side operating pressure and convert it to temperature using your temperature pressure chart. Now plug these numbers into the formula. The actual superheat is 13 degrees. Record the superheat on the invoice for future reference.
It's important to understand that the amount of superheat will vary depending upon the conditions under which the system is operating. Okay, now the next thing to calculate is the amount of subcooling.
To determine the amount of subcooling, use this formula. High side saturation temperature minus liquid line temperature. Determine the saturation temperature of the high side by taking the high side operating pressure and converting it to temperature using the PT chart. To get the liquid line temperature, attach an insulated temperature probe on the liquid line leaving the condenser. Then plug the numbers into the formula to get the subcooling temperature. In this case, it's 20 degrees. Record the subcooling on the invoice as well. The system's superheat and subcooling are in the design range, which means it's now cooling as it should. To complete the service call, explain the charges on the invoice, make sure paperwork is complete, and answer any customer questions. In addition, suggest ways the customer could avoid blowing grass and dirt on the condenser coil when mowing the lawn.
Well, that's it for this program. I hope you've gotten some ideas about how you can sharpen your troubleshooting skills when servicing either standard or high-efficiency AC equipment.